Hello, everybody. I am Dan Pierce. I am a design director at the Fox Broadcasting Company at the TV network, and we do broadcast design for the promotion of the shows that we have. And Cinema 4D is one of our main tools, and I personally love it. And we have such a great team of talented artists that leverage it in such an amazing way. And it's always been such a great creative problem solver for some of the stuff that we do. So I am very happy that Maxon has invited me to share some of the things that we've been working on and how we did it and how Cinema 4D has made it so much easier. So let's just get into it. As I was saying, I'm Dan Pierce. I'm the design director at the Fox Broadcasting Company. And one of the things that I just sort of want to get into today is how Cinema 4D has helped us in in the development of our looks. Like in the end, we might only see 2 seconds, 3 seconds of our work on air, but there is so much, and this is one of the most rewarding parts of it, at least to me, is all the development that goes into it and how we can utilize all these different talents. Like I said, we have a fantastic team of very, very talented people that know a lot of different things. So we just try our development part of it is quite a lot of it, and we'll go through iterations and we'll figure out different ways to do things. And Cinema 4D is one of those things that gives us the chance to do that because it's really light and versatile, and we can just try different things without spending too much time on it and figure out if it's going to work. And two, we have artists that use different programs, but it always comes back down to cinema, and that's our hub, and that's where we'll render out and we'll finish everything. So here's just an example of some of the shows that we've worked on and all the different types of development that has gone into it. Now, in this presentation, I'm going to focus on one of the shows that we have called Masked Singer, which is right here. And here's some of the sort of development that goes into it. And I just wanted to show some of these slides just to highlight how we really stretch out and do lots of different elements. Like you can see up here in the top right, those were modeled in ZBrush. I think a little bit of Marvelous Designer. Here we have just figuring out some texturing. Here's some ZBrush shots. I believe this hair was made in Houdini, but the purpose of all of this is that it always comes back to Cinema 4D. We use Alembic files. We use all different types to bring in. We're an Arnold shop, and we just use that specifically. But I think it just goes to show, again, how versatile Cinema 4D is and how we can have all of these things, all of these wonderful things that will just come together in one place. And here is a little example of some of the stuff that went into one of the seasons of The Masked Singer. Right? A lot of stuff. So, and this is a few seasons ago. And what we've done over time is that we've just sort of built on it, and evolved this package into different things. And each season that we get new costumes, and then we just grab things out of that. So again, Cinema 4D, very, very important part of being able to iterate and evolve this look into new and more interesting things. So here, I have a promo of from season 4, which is this look down here. So you can just sort of see how it all come back together.
We just call the winner right now. people! No way!
The Masked Singer season premiere, September 23rd on Fox.
Fun, right? Super cool. I loved working on this show. I mean, it was stressful and, you know, all of the things that usually come with some types of jobs, but in the end, it was there's an energy and a playfulness to it that was always fun to work on. So, in this presentation, I'm going to, you know, just do a couple examples of some of the things that we worked on. We're going to talk about geometry and what that means and how to take it apart and put it back together. The ever essential cloners and effectors and fields. We're going to talk about dynamics, connectors. There's going to be a little talk about pi as well. How can there not be? Some espresso, and really just how rad Cinema 4D is. So let's just get stuck into it straight away. Okay, so let's take a look at this one as an example. As you can see on the left here, we have that something going on in the background, these totems that I was talking about, just relation to the different costumes and stuff. And on the right, we have the raw render of what's going on in the background here. Now, we always found it important to have some sort of, you know, expansion coming out in the beginning, just so we could sort of, you know, when text flies in or something like that, just a sort of moment of excitement. And we found that this kind of process on the right-hand side worked out really well, where it was dark on the front and then nice and shiny on the back. So as it flipped over, it had this like really great feel of things coming into the light, and you could really, your eye could really follow this expansion. So let's just jump in straight away and see how we built this, because in the process there was a lot of things that we kind of learned and that presented themselves, and just through, you know, the power of Cinema 4D, you could just kind of like riff on things and figure out things on the fly, which is a fantastic thing to have. So as you can see, it's just kind of circles, and we always like to build things or start things in the most simplest form. So let's just use a disk, because that kind of looks like what we're going for right now. In display, let's put on some lines just so we can see what's happening. Now these are kind of like pizza pie shapes. We're going to want some more geometry on this. That feels pretty good. And then let's make it a little bit rounder. Let's just make round numbers here. Okay, that looks pretty good, right? So what we're going to want to do is, instead of, you know, we can break this apart and then make those the individual little pieces. And so what we want to do, if you press C, that will make that editable. So as you can see now, we got all these like little different panels and stuff. So, but we want these to flip around individually, which, they're all connected. So how do we disconnect these things? So what we're going to want to do is we can go up to mesh, and then we can go to clone, and then we can disconnect. So now this, we have an option here. Do we want to preserve all the groups, which means disconnect it, you know, GeoWise, but it still retains one thing? Or do we want all of these as individual pieces? And of course we want all of these as individual pieces. So I am going to uncheck this, and then I am going to press OK. Now, cool. So this should all be disconnected. So if I just pull this off, looking pretty good. But now I'm going to want to control these individually, but this is still one piece. So there's got to be one more step here where we can break it into other pieces. So actually, before I do anything, I am going to flip my normals. I don't know, this is just one of the things I like to do. There we go. That color is better. So you can kind of see this is just telling which way's up. I feel a lot better about this. Thank you for indulging me. Okay, so now to break these apart, we can go to conversion and then polygon groups to objects. So if we click this, if you watch over here, something's going to happen. And then all of a sudden, this becomes a group. And now look at this. This is great. We have all these individual pieces here. And these we can just move individually. Now, what it does, to its credit, this remains the original one, and then it just creates duplicates of all of these. So we actually want to get it out of this because this is still the full one. And one of the things that we can do with MoGraph is if we put individual pieces into a fracture object, then we can still leverage all the power of all the effectors on individual pieces. So this really comes in handy for a multitude of reasons. So let me just drop it in here, and then I'm going to hide this old one. We can save that for later, just in case we need to do it again. So now we have all of this, and let's just put a plane effector on it. Okay, cool. That happened straight away. And what's our parameter here? So it's going up 100, which is what we want. But we want different things happening to it individually. So we're going to need some fall off because it's working as a whole. One of my favorite ones is, I'm actually going to turn this a little bit down so we can see this better. I love using the torus, especially on these sort of expansion things, because it's a donut. I mean, it goes out in a radial way, and there's kind of an on and an off. You could do the same thing with a spherical, but it's kind of on the whole time. So, okay, well, you can see that now they're doing it individually. I just have this facing the right direction, so let's do Z. Okay, pretty cool. So now this is actually moving that in position. Let's try with scale first. Let's see how that works. So let's just so we can see what's going on. Let's do -5. So this is going to make it. All right, so we're already off to the races here. This looks pretty cool. And now we can just start animating these things. And now these are all going to work in individual ways. So let's make these come up too. That'd be pretty cool. Or down. Look at that. You know, the fall off now. So now, actually that might be a little too much. So now we have this whole thing going. So let's animate this. Now I'm kind of particular on how this goes. So let's start from total 0. And if you option click, I'm on a Mac, option click the radius, that's going to do a keyframe. And so we're starting at nothing. Let's just say 10 frames up. Let's go kind of all the way through. Option click again, set another keyframe, and let's just go all the way to the end and make it go all the way through. Cool. So it's all the way. Now, that looks pretty good. So we can see that affecting those individual pieces. Now, I want to look at the curves on these keyframes, just make sure everything's going good. So if you actually right click on this, you can go to animation and then show F curve. And then this will bring up this window here. So this is actually pretty close. However, this is telling it, oh, go a little slower, faster, faster, faster. And I actually want this to come out like super fast. So now we have this coming out pretty fast, and then it tapers off into something. And just bring this down. This means this is going at a linear rate, pretty much, because that's pretty much just not a straight line, but a constant sort of angle to that. Okay, so now to close that. All right, so that's pretty cool. Now, the next thing that we're going to want to do is let's try out some stuff. But you know what? It does remind me of something else before I get into this, is that whole process of breaking these things apart and putting in a fracture object, we actually leveraged that on something else that we did here. And this was for the upfronts here. Let me just play this. This is for the upfronts. And I did this with Sabor, who is also a presenter today. Fantastic designer, animator, director, and overall great person too. So we went through this and figured out how this worked. And it was using the same process because we needed to specifically break these down into specific sizes so we could put all of these logos in. And that's how we figured out how to do the other things. So let me just jump back into Cinema here real quick and just make a new project. I can just run through this really quick because once we figured all of this out, it just made our lives so much easier. And funnily enough, too, I have used this process on all different ways. So again, another great thing of just like problem solving in cinema and then learning things, and then that gets applied to other stuff. So let me just make this flat plane here. And as you saw in that animation, we needed to have particular blocks. So if you press U, it will bring up a menu. I just know this from habit. And then Z would meld this into one piece. And then let's say UZ, let's make this bottom corner over here. Actually, let's make this big one, UZ. Let's make this one, UZ. Let's do one more over here. UZ. Okay, so now we got, actually, let's do one more. UZ. Now we have this here, and you can kind of see where it's all broken up. So now we needed to do the same process of like, how do we break these into individual like little pieces? So we went up, took our, my UVs, my normals, sorry. There we go, that looks better. So mesh, clone, disconnect, make sure unpreserved groups, mesh, conversion into polygon groups. So now we have all of these individually. Let's just take this out of that first group. Boom. Okay. So now we can just put all of these into a fracture object. But what we're going to have to do, because they're, look at this, all by itself now. But what we're going to do is we're going to make this we need some depth to this. So if you do MT, you can extrude these out, which is what we wanted. But one of the things I always like to do, create caps, which means on the back, when you pull this out, it will actually keep a backside to it. So let's just pull this out. And then if you do I'm going to have to look at this. Inner extrude, MW. There we go. Just kind of make a tiny little edge there, right? And then back to MT for extrude, and then just go, whoop. Now we have to take out the cuts. Go back the other way. Now we have this, I don't know, essentially like a cabinet with specific like little places that we can put things. So now these are just the individual little boxes, but very specific to whatever we wanted, and we could design it and customize it. Now, this is fantastic that you can do something this detailed this quickly, and I thought this was super impressive. So let's just drop this into a fracture object, right? Okay, and now we can leverage all of the effector stuff again, which is great. Let's just do a linear fall off on this so we can see what's happening. So that's pretty cool, right? And now you have all of these pieces happening individually. Now, we wanted them to just kind of like rotate over, which was good. So they wouldn't like they wouldn't intersect as they came over. So we had to figure out a few things to it, because I changed this parameter to like rotation. I never know which way the rotation is. This happens every time. I just go, and just enter here until I find out what I want. So I guess I want P, which I think is pitch. I think that stands for pitch. Okay, so now that's great, but it's rotating from the center axis. We don't want that. So let's just turn this off for a sec so we can see. And then we take these, and then we can just go to axis, and then let's look at this axis center for a second. So we want the bottom and the back, so it just rotates and just flops over. So definitely 0Y. So then we'll take it to the bottom, and then, all right, here's where the guesswork comes in. I'm thinking that's backwards. So let me do that, and let's see. So now all of these should have their access points in a plate. Oh, look at it. I chose wrong. No problem. We can fix all that. Let's just change this to this way. Cool. So now all of these individual pieces have their rotation in the back here. So, okay. It still seems to be off a little bit. Another little trick that we learned in this is that we had to put these into null objects for the axis to be respected. For whatever reason, I'm sure someone smarter and better at this than me can tell me why and probably figure out something else. But again, this was another highlight of cinema where you can just, hey, let's just try this until something starts to work. So if I selected all of these, I held down Option and went to null. Now these nulls were placed, this was placed inside a null, but the null also was where the axis was. So let's turn this back on. And then now that's starting to work from where we want. And that's pretty much how we went through all of these. And then, we ended up using Signal for this. Sabor figured that out and it worked really well. But also, we could do this and then actually Z2. Let's just go full 90. So you could essentially do this and they would come up and reveal itself. And the benefit of also having a null is that we can put objects within it too and just like really, really stack it up, and then everything would just be responsible to the null. Okay, so that is a little side thing. Let's go back to our other project here. Okay, so we're here. So we were just talking about rotation. So let's try the rotation on this too. All right, like I said before, I always stumble through these. Okay, that's not what we want. We want it to sort of like flip over. Oh, that's weird. It seemed like it's gonna work too. So theoretically, we could probably figure out some sort of null thing. I think it's just, trying to rotate these around a different axis point from each one of these pieces. And it's not exactly what we're going for. We just want to clean kind of swivel over, just like a flop over. So that is not exactly working. So let's kind of figure out a different way to do this and then get the effect that we want. So we could probably go through and do all individual, figure out where all of the axis points should be, but there was actually another way that we came up as we were doing this that seemed to work out pretty good. So let me just go into a thing because we're going to use some cloners, but we have to make some, here, let's just go full screen. We have to make some objects first. So let's just, again, just saying, let's just keep this as simple as possible. So let's just do a plane. See, I'm sure this is far too big. Let's see, I don't even see it. Oh, there it is. Okay, I see it now. So let's just say that's kind of the size of that, but close enough. But what we're gonna do is try and, you see that these are smaller in the middle and then get bigger, bigger, bigger as they go out. So we're going to try and replicate that kind of feel just with another approach. So we have this established. And what I was saying before, let's just keep this as simple as possible. So 1 and 1. So this is just essentially just one polygon. So let's just keep this nice and simple. All right, and let's put this in a cloner. And by default, it's going to be a linear one, which in this case, we actually want. So this obviously too much space. We know that this plane is 20, so we want this too. So now it's like side by side by side. And let's just say 8 for now. So what we're going to want to do is make this essentially a pie slice. And one of the things that work really well in doing this is if we just use the deformer here, the taper, we can make this, squinch this down, like here, let me just squinch this down into a a point here. Now, I sort of have a love-hate relationship with some of these deformers, especially when I'm trying to like figure out sizing and like how to get it. There is a really great function that it's fit to parent, but I can't make this a child of this because it will just repeat itself. And see, here's the fit to parent. I want it to be the actual size of this entire thing. So to have it work, if you select both of these and then Option G, it will put it in a group. And it's a hierarchy thing. So this will affect what's going on above this. And that way you can stack different different deformers and stuff like that. So now I got to figure out, well, I know this is 20 wide. Okay, so there's a start. Let's just make it 20 deep. Now, the height is where it's going to come into it. Well, I can do a little bit of simple math. I know I have 8 here, and then it's 20 high, so let's do 160. Okay, well, pretty good. However, I think the axis is where it's doing the math is a little bit off. But here, let's just activate this. Looks like I'm going in the wrong direction too. All right. Whoops. Let's make this go around 180. Okay, so that's good. However, it doesn't seem to fit properly. And if I want to do more, it's just not going to work out that way. So one of the things that we just dipped into just really quick to try and help this along is there a way that we can just sort of like adjust one thing and have everything work the same? And of course, we have Espresso in Cinema to do that. And like, I'm no math whiz at all, and it's really, really intimidating. However, if you just sort of like just take it step by step and leverage, the sort of like tricks that they have in there just to make it a little bit more easy and a little bit less overwhelming, it is actually a really functional tool. So I think what we want to do, well, we need to figure out how we can match the height of this and still have this change and have this respect that. And that's probably where the position is, because it seems like that's off as well. So let me just, I'm going to put an espresso here. So if you do Shift C, you can search for anything you want. So I'm going to do espresso and just put a tag on here. And I'll just put it on this null just to make it a little bit easier. So we're going to want information happening with the taper, right? And then we're going to want information coming from, see if we can base everything around this. I'm going to change, just to this simple thing. And of course, we're going to need some information in the cloner as well. So let me just make these a little bit bigger. All right, so what are we trying to do here? We are trying to figure out the taper size, that X height, and then probably the X position as well. So let's just kind of think this out first. All right, so the taper height equation, we have the panel, let's just call it X, and then the cloner count, I think I already did that, would be the taper height. So pretty simple. X, I'm just using variables here. X times n equals c, which, 20 times 8 cloners equals 160. So that's a pretty straightforward thing. So how can we figure that out? So first thing though, and one of the things that I love and discovered about Espresso, I used to go through and like right click and like try and find all of the parameters that are in these things to be able to put it together. Turns out you can just drag and drop it in there. So I can just drag this into here and look at that. Now it's got that port. And so this way you can be like, okay, what parameters do I need to use or have? And then you can just drop them right in here. So what do we need with the cloner? Probably the cloner count. And actually, you know what? We can use the panel height to drive the the x part of the distance between the cloners. So look, we can just do that immediately, okay? Because what would be cool now is if we just change this, then the cloners will always be next to each other. There'll be no gaps. And then, okay, so we probably want a cloner count as a little bit of math. So look at this, just drop it on that side. And then with the taper, what information do we need with the taper? Need the X position. So let's just drop that in there. And then with this one specifically, you actually do need to go and get something because I can't split that XYZ. But whenever you need a very specific thing, you just go to object properties, and this will have all of the stuff that's specific to the thing that you're going for. So let's just do size-wise. Okay, so I think we have all of this mapped out. So what's our first equation? Another good thing is you can just search here. I know it's going to be math, so let's do math. So let's start here. So we want the height of this panel times how many cloners there is. So let's just do, here's your first input, and then here's your second input. And then inside this node, you can just say, hey, what do you want to do? I want to multiply. I want to multiply this times this, and then that will equal the size. And there you go. And one of the things that you can test that is there's a result node. You can just port it in there. And 160. So 20 times 8 equals 160. So now we know that the size of the taper should be 160. And if we change any of these values, it's just going to reflect all the way through, which is super cool. Okay, so there's our first part. Here, let me take the strength off this so we can see. Now, the second part of this is the position of it. So the way that the X position is, the Y position is, it's just half of the height because this is always going to be in the middle. And that might not reflect the same with the cloner, but the way the taper works, it will always be the same. So if you think about it, we have this result here, Z, half of the Z will be where the position, so wherever the height of the taper, just half of that, and that will be the exact center of the height. So let's just do another math node. It's easy. So we wanted one result, this result, and port that into here. Now you don't always need two things because you can, if you look here, you can just go divide by 2. Let's do another result so you can see if I can spell properly. So it was 160, so it's 80. So we know what that is. So let's just do this and then port that back up here. Now that seems to be off. So something's not right here. I wonder, here we touched on the null previously. I wonder if this has something to do with it. Let me take it out of here for now. Oh, look at that. Okay. So look, that is pretty close. Let's try some of these things. Let me change the count. That's working pretty good. Look, that's like totally locked in. I gotta say, I still get excited when these things work out, but we're off a little bit. And I think that's because this panel, this again is, this point is, the cloner is starting from the center of this first panel, which means that it's half on this other side. And the taper is starting from 0, essentially. So we can adjust that too, because we know exactly what this panel size is. So let's just go back over here. One more stage to this. Okay, so we figured out the taper height. Great, Z. We ported that into this one. Awesome. And then we can actually use this. So this minus half the height of this X. Look at that. D is the true overlord of the taper position. So we're just going to have to add a few more nodes to this. So let's just go back over real quick. Let's open this up and put this. All right, so here we have this and we have this. So we need to add a few more things between this. So it's almost like this and this, it's got to go. So we know we have to do half the amount. We got to get one bit of information. And as we did with the height of just like splitting it by 2, so we're just going to port this in. And then we're going to say divided by 2, which will give 10. And then we got to do this minus this will go back into here. So one more math node. And we can go this one, which is the height, minus 10, subtract, and then go, oh, hold on, let's do a reveal here. Let's see if this goes down here. Come on, can do this. Sweet. Now we have a total rig that is responsive to just 2 parameters. So now we can see that this will always stay the height to this no matter what. And then if we change the cloner count too, everything will be locked in. That's pretty amazing, right? So just doing this, I know this looks a little bit messy, but if you sort of like think it out in your head, this has to happen, this has to happen, this has to happen. You just look inside Espresso, figure out which parameters that you want, and then that's it. It's really quite amazing that I self-admitted non-math genius could just sort of stumble my way through here just with a few math nodes. So this is really exciting. So, but the next thing that we want to do is we got to get this taper going. So now, like I mentioned before, we can't get it in there. Here, let's just put this back into the null. Back into the null, and then see what happens. Well, that's being weird. Here, let's create a new null. Maybe it has something to do with where the espresso. Look at that. All right, so we want this. Make that work. All right, so let's, I like pie. Call it that. Let's be cool to our friends and always name our things. Okay, so now we have this, and we can just port that right into a MoGraph. We want a radial thing, so let's just put this into a cloner. We do not want linear, we want radial. That's kind of cool, but that's not what we're looking for. Let's go this way. Hey. All right, now we're getting somewhere. Let's just get that. You know what? Here we're gonna go. So now we just up the count. And one of the things, once you start doing all of these, there's this wonderful instance mode. Let's just change it to multi-instance. It'll just make the performance a lot faster. Okay, so now we have a total pi. Look, a little bit of a gap. A little further. Okay, so now let me just take the visibility off this. So now essentially we have the exact same thing happening here. And since these are individual pieces, it's going to respond in a different way. So we can actually just take this exact same effector that we had previously. Let's turn this guy back on. And let's see what happens. Okay, that's super weird. Why is that not working? Huh. Oh, wait, we have a cloner inside a cloner. I wonder if we change it here, because this is the individual pieces that we want. Let's see if this works. Oh, that's it. So again, just to touch on the hierarchy of how these things work, it's just important of like order. And you saw how hard that is. It's like something's not working, let's just try it in this. And that's again one of the fantastic things about Cinema 4D is that you can just go back and forth until you find what you're looking for. Now let's go back into the parameters of this, because I think I got this all wonky. All right, this is looking better. So I want these to like flip over completely. Let's just mellow out this flip over too. Obviously we can change this again. If you just do right click and F curve, we can just make this bigger so we don't have to like keyframe anything. So let's just pull these up so it gets bigger. Cool. Great. All right, look at that. Everything just sort of like live happening, all just rolling with it until you get what you want. So actually, I'm going to take off this scale, and now we have this cool just sort of like thing going over. And if we have one side dark, one side bright as it catches the light as it goes over, that's kind of how it worked out. So let's just go look at this one more time. Pretty amazing, right? And look at all the different things that we learned along along the way of like how we can leverage and just sort of like riff with it and just figure it out on the fly. It's really fantastic for creative solutions. So let's move on to the next one here. All right, so here we have another background, one of my favorites here. Let me just play this. Now, there's always a costume that has some sort of feather. So when we sort of like lean in to try and distill out of what the costumes are and just trying to pick out elements and stuff, one of the things that we always appear somewhere is a feather. And this is this nice sort of like, I don't know, twirly tunnel that we made. And actually, this is from season 3. So this was back when there was no fields for effectors. So I was just using shapes and different techniques to get to this point. And so when going back, since this was still one of my favorites, just in terms of looks, going back to actually see how we could modify it and make it a little bit better and a little bit more dynamic, it was fun just going through and making this again. So let me stop this and let's go over to Cinema 4D and start checking it out. Okay, so we have this feather here, and we're going to want to apply it. Cloners. That's always the best place to start. Now, just like the previous one, I always like to just base things off of like the most simple geometry or shapes or that kind of stuff first. So this is a helix. You can use it for corkscrews or twists or any of those things. It's a really useful thing because it has so many different parameters here that you can dial, and you can really form it into different things. I use this for paths for cameras as well. Just get nice, even rotates around if you want to come down something. So I always just look for the simplest thing because a lot of times the simplest solution is usually the best. So, but this default shape is not what we're looking for. So let me just change the inner radius so it starts a little bit further in, and I think we'll probably need to make it a little bit bigger as well. Okay, so that's good. We got a lot going here. And then, but we're gonna want it tighter, like more revolutions in here. So one of these things. Oh, and I just want to point out really quick that all of these entry fields for parameters and stuff, it will do math for you. So I always look into it like, say I want 4 times the amount in here. Like, I wouldn't know what that number is. I'd have to get the calculator out. But you can just go, boom, look at that. Asterisk for multiply times 4. It looks like it's 2880. All right. So you can do this plus, minus, multiply, divide, all that kind of stuff. The other cool thing too is if you want to do, it will actually change the units as well. So if we do inches, it will change it to what it is in centimeters, which totally blows my mind. So if you have like a variation in what you have measurements on, you can just type it in there. So these fields are actually really powerful. So this is kind of like a cone shape, which I'm not really into. So let's just make the height 0. Okay, so this looks more like a heating element, and just nice and flat and tight. And we can make things come out in different ways. Okay, so have our helix, so that's the shape. We have this geometry is what we're going to apply to the shape. So if I hold this, hold down Option, go to Cloner, it will apply, put this inside the cloner and apply it. So default is linear. We do not want that. Let's just go straight to Object and then drag this right into the object. Okay, so we have it in here, obviously going in the wrong direction. We don't want that at all. So just easy ways to fix this up. So I also like it evenly spaced too, because if you start with it even, then you can add a variation to that afterwards. So let's just put a few more in here, just so we can see what's going. Now, if you go to the transform flag tag inside of cloner object, you can do global changes to these things. So I know that I want to get it at least 90 here, so it's flat. But see, since they're curved, you don't really, I'm worried about overlap, to be honest. So I'm gonna over crank this, so let's go to 120, so it's up a little bit. So that's good, cool. And then maybe we just wanna change this direction a little bit, just so it's sort of like an outward kind of thing. Go. Okay, that's feeling pretty good to me. However, we want some more density to this. Let's go up to 400. That feels pretty good. However, there's lots of gaps in here. Before I get out of this area though, these instance modes, you can change it to different. So if you have tons of cloners, you can actually change it to multi-instance, and the functionality and the performance will greatly increase. So let's just do another global change here. Let's just double the size. Okay, that feels pretty good, right? So now we have our shape. That's looking pretty good. So let's do some effectors on it. Now, just to save the boredom of me doing my beloved torus field again, I have one set up here. So I'll just activate this. This is, I'll drop it in here, but it's the same as the other one. It does a quick expansion at the beginning, so you can see here, and it will go through. But what I have it doing is I'm having it sort of like ripple out and go through, and then as it passes through, it goes down. I also have a little bit of rotation on there too. Here, we can just look at it real quick so we can see what's going on. So I got things moving, and then I dialed this in. Save you the trouble of watching me do this endlessly until I start feeling like it's good. So let's just look at this real quick. And that has a nice feel. You know what would be cool too? Let's just rotate this guy a little bit. All right, so like I always say, I never know, which direction's which. So it must be this one. And then let's go to the end, and I wanted to go this way. Let's just say 20. Now, the default is it'll sort of like be easy in, easy out on this, and I actually just want to continue this one. So let me right click on this, animation F curve. All right, so you can see it starts slow, gets faster, and then it starts slowing down. I actually want it just like straight linear. So you can select them all, you can click this, and it will just do it for you. Or sometimes what I do is I right click it and I'll go to 0 length, and that will flatten it out, but it won't make it a linear keyframe. This is still a keyframe where you can do a curve on it. So let me do that, and then it should be a constant pace the entire time. Okay, so let me get rid of the visibility of that. All right, so this is looking pretty cool. However, I just want a few more like different variations to it. If you just layer this stuff, and it starts to feel pretty natural. So let's do a random, because I do want something random. So if your cloner over here is selected, and then you just go here, it will automatically put it in here. And also remember, you can reorder these. It depends how much is layered up, and it does play an important part. For this is pretty simple, but if you need something to, especially if you have like one parameter, say the X direction or the X scale, only on one, and you want that to happen before some other one happens, then order here is important too, and you can mix them as well, which is super cool. Okay, so back to here. So I just know from writing down what this is. So I actually don't want that much of the position. So I'm just going to do like 2, just barely. However, I do want a fair amount in the rotation. So let's do 30 here. So even now it's starting to feel a little bit more ruffled and better. So now all of those 2. Okay, so that feels pretty great. All right, so let's look at this again in motion. Cool. All right. One of the other cool things, without having to keyframe anything with random, if you go to this tab, the effector tab, this random mode, if you change this to noise, this will actually start animating the noise to it. You can sort of see a wobble here. Not really interested on such a fast one, so you just change the animation speed a little bit slower. And then the scale is, if you can imagine, sort of like a fractal noise, what's generating this. I kind of want that a little bit bigger, so it feels a little bit more natural. Like if it's small, here, I'll overcrank this. So you can kind of tell, but hey, if that's the effect you want, then that's cool too. So back to this, back up to 200. Okay, so this is feeling pretty cool to me. All right, but the other weird thing is I'm not exactly happy with, if I start going through here, you can see I'm getting some intersection here, which, in the grand scheme of things, and it goes pretty quick, it's not going to be a huge deal. However, is there something that we can do about that? I know we can do dynamics on cloners, so let's try that. Let's just put if you go to simulation, rigid body, let's just do that, and let's just see what happens. Press play. Okay, well, we don't want that because that's all just going to fall away. One of the things I often play with is like, if we can just have this, we obviously want these to stay in place. If you click Command D, will bring up your project settings, and there's a dynamics tab here, and it has gravity, so you can actually change the gravity of how much you want. Let's just zero this out and see what happens. Are they going to stick in place? Kind of, but they also start floating away because they have sort of like velocity inheritance from the effector going through. So, all right, we're getting a little closer. I mean, that's cool, but how do we get it to stay in place? So one of the things that you can do is even mix further sort of dynamic techniques in this. So let me just take this feather, go over. I have this other project here. Let me just paste this in. Now, just a quick note too, we version a ton of stuff. Sometimes our projects are super simplified and rendered down and figured out, or sometimes they're really complicated and some things need to stay in there and stay accessible, but we don't want to clutter up anything. We leverage the layers tab a lot, and all our great artists do their due diligence to name things properly and assign things into groups and all that kind of stuff, and it really does make for better workflow. Now, I'm using this one in particular because one of my favorite ones, actually, if you click here, it will show you what each one of these icons look like. For me, it's the manager. It's like, I don't want to see it up in here, and you just click this. Now it's there, which is incredible to me. Or you can just like clean everything up and just have whatever active thing that you want in there. So let's see how this is going to play out. So there's a thing called a connector. And if you can just imagine this as a hinge or any of those things here, let me do Shift-C. We'll do another connector. So Shift-C searches everything. So sadly, I don't know where everything is in the menu. So I end up just like typing things and will come up. So if you can see in this one here, there's all these different types of movements that can go. But most importantly, this means that this will stay in place and orbit around an axis or a combination of axes or move like that. So this might be a good way to be able to anchor this in, still have dynamics applied to it, but not have it float away. Hopefully it will be remain sort of like locked into where the cloner is putting that on the hinge. So the way this works, it's actually quite simple. So here, let me clear this. It's just saying, hey, I need one thing for it to be. We know we want the feather to hinge. Now, let me just go with that. Now, the other thing is you just need to place, you need two items. You need what's going to swing and what is sort of like holding it in place. And right here, I just put a null here. That's all I need. It doesn't need to be geometry. It doesn't need to be anything else. And I just put that in here. So what I'm telling it is this feather can orbit around where the hinge is. Really easy. So let's press play. Well, nothing's working because you need to put a dynamics tag on this. So rigid body, let's just press this. And apologies, that is something I'll get into in a sec. So press this, and there you go. You got a hinge. Now, is this going to work inside of a cloner? Let's try it. Oh, weird. So if I do it like that, it will just default to this first and completely disregard the connector. So I wonder if there's some hierarchy thing that we can do. Let's just make these two children of this. Let's see what this. Oh, that's pretty sweet, right? Look at that. They're even interacting with each other. That's incredible. So this is definitely what we're looking for. So let's put this back. We're going to steal this one. We're going to go back to our other project here. And then we're just going to do the old switcheroo. So let's take this. Put this in here. I'll take this one out and just hide it. All right. So now, hopefully, we got something going on here. Oh, wait. We got doubled up dynamics tag. So let's get rid of this because we know this is the one we want. And here's the connector, too. So let's just see what happens. Ooh, that's pretty wild. It is coming off a little bit, though. So let's see how we can limit that. But that's something too. And then just to highlight, just real quick, I don't want it to like orbit too much, to rotate too much. So there's actually an angular limit here. So if you can imagine just, 5 degrees this way, 5 degrees that way, and it will sort of like limit how far it will go. It will move as a whole because of the dynamics, but in terms of the actual connector, the hinge moving, it will limit that. Okay. So let's think about this. How can we make this chill out a little bit? And here, let's go in closer so you can see what's going on. Okay, so inside the dynamics tag, there is a gazillion different things that you can choose. Here, let's, we're MoGraph and dynamics. That didn't really change anything, but I just feel better that it's that way. Probably don't want friction. So friction is like when it rubs against each other, it will sort of slow down. And then bounce obviously is like if it hits each other, it'll bounce a lot. So I wonder what other settings we have in here that will help. I know from previous things, this force, this follow position and follow rotation sort of dampens things down a little bit and mellows it out. Let's start at 2. Let's see how this goes. All right. And look, it wants to come back to its original place. So that's super cool. It's trying to find where it came from, but obviously it's still a little crazy. So let's go up to 5. Let's see how that looks. Okay, better. Here, let's line this up. That's looking pretty cool. Okay, so we're cranking even more. Let's go to 7. No, let's go to 10. Let's see what happens here. All right, there's some errant ones here. That might actually be too much. So let's go back to 7. Okay, so that's feeling pretty darn awesome to me. So now we can see, actually, here, let's do the animation speed up on this. So one of the great things is you can sort of just, do pretty much like live updates on this and just sort of tweak it until you get it to the place you want. So for me, this is looking pretty darn cool and natural. And if you texture this and light it right, as these things sort of like turn and move around and hit the light in specific ways, it'll work out. So one of the other things I just wanted to point out really quick is that to get this sort of look here, where it's all one and then just sort of like random ones, this was important to get the color palette into there. Now, our shop uses Arnold, and there's a way to sort of like randomly assign, and you can just tell most of it to be one color and then little bits and pieces, which is good. But if we want to do it this way, and I don't know if this is a cheat or not, but this is how I ended up figuring out to do it. So this will, you see here, clones, iterate, random, blend, sort. So this you can sort of like move around. Iterate just means it will just go from one to the next to the next. So actually, if I duplicate this here, you can go back to the beginning. Whoops, not the cloner. Duplicate this, and I do that by holding Command and then dragging. And then if I make that one red, so it will be one black, one red. Here's another one. Let's make that white. Okay, went back. So, but if you change this to random, it will sort of randomly assign it. And two, you can just like go through these and figure it out. But I want mostly black. How am I going to do that? So I figured, I don't know if this is a hack or not, but I would just duplicate these until I get to the point where I have the amount of black that I want. So there we go. I mean, that's pretty easy. If you don't have that functionality in your renderer, this is just a pretty easy way too. And it's still referencing this random here. And so you can just cycle through until you get to the combo that you like. So that's kind of where we got with this. Super excited to share that with you. The fact that you can mix dynamics and connectors and your cloner together just to make something really dynamic is exciting for me and how to elevate your work. Well, thanks everybody for listening. I'm looking forward to answering some questions from you. This was really fun to get a chance to do this. Again, my name is Dan Pierce, Design Director of the Fox Broadcasting Company. Here are some of my information. The Automator.tv is my website. If you just search Dan Pierce on Behance, I got tons of like BTS things and breakdowns. And then my Instagram is waiting for renders, but be fair warning, there is almost zero motion graphics on that. It's mostly my baking pictures. So just fair warning on that. And special thanks to the team at Visual Innovation Studio, which is the sort of agency, internal agency that we have at Fox, and the team there. And then, of course, Maxon. Thank you so much for letting me be a part of this again. I really love this. Hope to do it again soon.